Let me get my other recorder going here, then we'll start. There we go. Okay. We're taking a look at area of region between two curves. And we want to do a little bit of reviewing first. So let me get this up. And come over here. And the first one's asking us to find the points of intersection between y is equal to x squared minus 2x and y is equal to 7x. Try that again. There we go. 7x minus 8. Now, for points of intersection, these are both solved for y, so that gets us going in the right direction. We basically set the x squared minus 2x equal to the 7x minus 8. Now here we have an x squared, so we want to get everything over one side, 0 on the other. So I got x squared minus 2x minus 7x plus 8 equals 0, which is x squared minus 9x plus 8 equals 0. And as factors, as x minus 1 times x minus 8. Zero factor property, set each factor equal to 0. And we get x is equal to 1. And we get x is equal to 8. Now, if we were in algebra, we would find out the y value that corresponds to this. But we're going to find that this is actually what we're looking for in calculus. Excuse me. Let's see. Evaluate indefinite integral x squared from 1 to 3. Well, if you got x to a power and you take an integral of it, you add 1 to your power, divide by your new power. Then what we do with that 1 and 3 is we plug them in. So I'm going to plug the 3 in, and I'll plug the 1 in for the x. And then you put a minus between them. So again, this is the x is equal to 3, and that's the x equals 1. Now 3 to the third is 27. So we got 27 over 3 minus 1 to the third is 1. So 1 over 3. Since I already have the same denominator, this one comes out nice. Our answer would be 26 over 3. Let's see. Even odd functions and integrals x squared from -2 to 2. If I look at the graph of this, as good as I can freehand it. -2, and you have to use your imagination here. -2 to 2. I'm trying to find this area right here. Well, it's see how this symmetry here? This is an even function. It's symmetric to the y-axis, which means that I can just find half of this. I can find it from 0 to 2 and then multiply it by 2. So I can find it from 0 to 2 and multiply it by 2. Now this works out nice because 0 is easier to work with than a -2. So again, we'll add 1 to our power, divide by our new power. 2 to 0. So we got 2, and then I'll plug in these numbers. So I got 1/3 times 2 to the third minus 1/3 times 0 to the third. Well, 0 to the third is 0 times 1/3 is 0, so that drops away. So we got 2 times 2 to the third is 8. So this is 8/3, which then gives us 16/3 as our answer. Four, the U-substitution. We got the integral of x e to the x squared minus 3 dx. Now remember with the U-substitution, when we have e to a power, one of the things we try to do is we try to let u equal to the power. So u is equal to x squared minus 3. du would be 2x dx. Now we don't have a 2 up here, which we have to since there's a 2 here, so we'll put 1 in there. Now we'll offset that by putting a 1/2 out in front, the reciprocal of this, because 1/2 times 2 gives you the 1. Well, now that I've done that, this gets replaced by u, and 2x dx gets replaced by du. Now the integral of e to the u is e to the u, and then we'll put a plus c in, because this is not a definite integral anymore. And then we plug the u back in. You said u is equal to x squared minus 3. And that would be our answer. Now there's other ways we can do the U-substitution. Definitely if you have e to a power, you can try to let u equal to that. If you have parentheses to a power, you can try to let u equal to that. Goes right along with this one. If you have radical of some form, you can let u equal to what's inside the radical. And if we have a fraction of some sort, you can try to let u equal to the denominator. So these are just some of the different u substitutions that we've seen. There's a lot of them that you can do, but these are just four basic types. The unit circle. I should have had a unit circle downloaded, but you'll have to make do with my sloppiness. If I look right here, this is pi over 4, and we got square root of 2 over 2 and square root of 2 over 2. Now we're trying to find sine of pi over 4. Well, here's pi over 4. Sine is our y, so unfortunately these are both the same, but our y would be square root of 2 over 2. Cosine is our x, so it'd be this. Tangent is y over x, so it'd be this over this. And then of course the cosecant, secant, cotangent are reciprocals, so they're easy to get. Number 6 goes right along with that. Got sine x is equal to 1/2. Oops. Try that again. Okay. There we go. If we look on our unit circle, actually, let me finish doing this. There we go. If we look on our unit circle, we're asking when is sine of what is equal to 1/2. So we go around our unit circle looking at all the different points, and we see one here. Sine is our y, and here y is equal to 1/2. So one answer would be pi over 6. And over here, it's also equal to 1/2, so it'd also be 5 pi over 6. Now I didn't specify it in the instructions here. I meant to. We're only looking at the just the unit circle itself, not going around it twice. So we're going from 0 to 2 pi, which these would be our only answers. Again, this is just kind of refreshing your memory on these, so you know how to do them on the problems. Integral of 1 over x or 1 over u. Well, let's just look at 1 over x dx. Whenever you have 1 over x, that's a natural log of the absolute value of x plus c. And that'd be your answer. Let me save this because I'm ready for a new page. this? Area of a region between two curves. Area of region between two curves. Page 01. There we go. Okay, so let's look at this problem. It says set up a definite integral that gives you the area of the region. And actually, let me write the formulas down here first. I'll wake up here eventually. We have two different types. We have type 1, where we have a graph here and we have a graph down below it. And then we're trying to find the area in between them like that. This comes down here, let's say A. This is B. These are specifically here x values. So when we're talking about the limits, they have to be in terms of x. So I'm going to go from A to B, and then I'll have the graph above minus the graph below, dx. So if you got this kind of set up, then this is the best one to go with. Now specifically, these have x's in them. And we're going to see what that means when we start looking at examples. And then we have type 2. And so I got a graph there. Got a graph here. And come over to here. This is my A and this is my B. Of course, these are my Y values. And our setup would go from A to B. And this is the graph to the right minus the graph to the left, dy. Now specifically, these have y's in them. So those are the two different types you run across. So let's look at this problem now. We got y equals x squared minus 5x plus 4. And we got y is equal to 2x minus 2. And we're wanting to find this area. Well, obviously the blue graph, the line, which is y2, is above this right here. It looks like it's going from 1 to, don't know what it's going to, 6 maybe? So from 1 to 6, and this is above and this is below. Well, let's find the points of intersection and see if that truly is 1 and 6. So, and that's what a lot of these problems revolve around. If they don't directly give you the limits, you have to determine yourself by the bounding area. So to find the points of intersection, we set these equal to each other. So we got x squared minus 5x plus 4 equals 2x minus 2. We have an x squared, so I get everything over one side. So I got x squared minus 5x minus 2x plus 4 plus 2 equals 0. Or x squared minus 7x plus 6 equal to 0, which is x minus 1 times x minus 6 equal to 0. Zero factor property, you got 0 on one side, factored that, set each factor equal to 0. So x minus 1 equal to 0, x minus 6 equal to 0. And we get 1, and we get 6. No big surprise. We could kind of eyeball that and see that. Now, specifically, these have x's. and these are in terms of x's. So this is type 1. So we want our graph above minus our graph that's below, and then dx. Well, we set our little graph that's above from our picture is that blue line, which is the 2x minus 2. And then if I look at any individual point, the graph that's right below it is the red, which is the x squared minus 5x plus 4. Now all they're asking us to do here is set up the definite integral that gives the area of the region. I'll go ahead and simplify this, but I won't actually find it. So that gives us... Try it again. Okay. I don't know why I was making it so big. We got 2x minus 2. Negative out in front of this flips the sign of everything. So that's negative x squared plus 5x minus 4 dx. Which then gives us, let's see, negative x squared. 2x plus 5x is 7x. Negative 2, negative 4 is negative 6 dx. Now that's our setup on that. Okay, let's do the setup on this one. Now, notice how this is in terms of x's, and looks like it goes from negative 2 to 2. So it's perfect form for type 1. We got our graph that's above, and y2 equals 0. That's this line right here. It doesn't really show it, but that's the x-axis. Well, let's find our POIs, just to verify. Actually, I guess I should write the problem down first. Negative y equals negative x squared plus 4, and y is equal to 0. So I got negative x squared plus 4 equal to 0. I'm going to take negative x squared to the right side. It becomes a positive x squared. Square root property. Drop the squared off and put a plus or minus square root around the other side. Well, square root of 4 is 2, so we get x is equal to plus or minus 2. No big surprise. It'll look like negative 2 and 2, but you don't know for sure. It might be 2.01. So that's why it's good to find it, even if you can visually see that, because you never know. We said it's type 1, so negative 2 to 2, and we got our above, and we got our below. Our graph that's above is this red, this curved graph, which is a negative x squared plus 4. And the graph that's below is the 0 here. So put 0 there. And then I'll do a little bit of simplifying. I won't actually find it because it's just asking for the setup. So I got negative x squared plus 4. The 0 doesn't actually do anything. And that'd be your answer. Let me save that. And we'll look at the next problem. What? I hate when Windows does that. It's like, I don't want to create a system recovery right now. Okay, I guess it saved that page. Let me do it again just to make sure. Okay. Should develop a new Windows operating system. I know you're busy doing something right now, but I wanted to pop in right now and interrupt what you're doing because what I have to say is much more important than what you're doing. Called Rude Windows 95. Okay. It's negative x squared plus 2. Okay, well, look at this. Of course, the shaded region, that's the only part we're concerned with. The blue here is above the red here. It looks like it's going from negative 2 to 2. So type 1 is going to be the one. These are in terms of x's, so it's in perfect form for type 1. But let's find our POIs. So we'll set x squared minus 6 equals negative x squared plus 2. I'm going to take the negative x squared here, move it to the left side, take the negative 6, move it to the right. So I get x squared plus x squared equals 2 plus 6, which gives us 2x squared equals 8. Divide both sides by 2, and we get x squared is equal to 4. Square root property, drop off the squared, put a plus or minus square root around the other side, and we again get plus or minus 2. Okay. So we'll do type 1 from negative 2 to 2. And we got our above, and we got our below. Now if I look at this, the blue is above. Now the blue is it's a parabola, but it's opening upside down. The negative is what causes that, so that's y2. So we'll put negative x squared plus 2 here. The red is opening up. That's just your normal x squared. If you have x squared, it's a parabola opening up. So that goes, what did I say, minus 6? Yeah, right there. We'll do a little bit of simplifying. So this gives us negative x squared plus 2 minus x squared plus 6 dx. Negative x squared is negative 2x squared. 2 plus 6 gives us 8. And that would be our setup. Now I'm not sure if in the book they're looking for this first one or a little bit of simplified form. But again, they're just kind of looking for the setup on that. Okay. Now let's take a look at the next one. Oops. What in the world? Oh, okay. I was afraid I deleted a slide with my fat fingers. Okay, so 4. It says the integrand of the definite integral is a difference of two functions. Sketch the graph of each function and shade the region whose area is represented by the integral. And notice how everything's in terms of x's. This is dx, which means this is type 1. So from 1 to 4, and we got x squared minus 4x minus 2x minus 5 dx. So this is going to be the graph that's above, and this will be the graph that's below. Now I'm going to do this on the calculator. I could do this and put it into standard form. Like if I if I took half of this and squared it, that'd give me 4, so I'd have plus 4 minus 4, and come up with the vertex that way. But again, I'm trying to emphasize the calculator, just out of curiosity. I do like things by hand. This is our graph that's above. Y is equal to x squared minus 4x. And again, what I do is I take the negative 4 times a half squared, which gives us negative 2 squared, or 4. So I'm adding 4 and I'm subtracting 4. Then we can factor the first 3 terms here. This factors as x minus 2 squared minus 4. And then our vertex would be 2, negative 4. 2, 3, 4. Now I'm really interested in actually 2, negative 4 would be right there for the vertex. I've been spoiled by calculators so much I forget some of my old techniques I used to know. Okay, let me go back to this. If I were to put 0 in here, that'd give me 0. And I want to be more precise than that. It's probably, well, let me do 1. 1 squared is 1, minus 4 times 1, that's negative 3, which is right there. So, not that I'm very good at freehanding these. That would be our graph. Now 2x minus 5. 1, 2, 3, 4, 5. And as good as I can get a straight line. It looks like that. And we're looking at from 1 to 4. And so here's my 1. 1, 2, 3, 4. So there's 4, and here's 1. So our shaded region would be this right here. That's what we're trying to find. Let me show it on the calculator. What you would do is you'd press your y equals, press your clear, and here you'd put in your first function, x squared minus 4x. So x squared, let me make that a little bit bigger. X squared minus 4x. Then down arrow to y2, and we put in 2x minus 5. And graph. Well, I'm zoomed funny, but I'll do a zoom z standard. So choose zoom and choose z standard. And we get that. Now, unfortunately, the calculator might be able to do it, but I'm not quite sure how to do it, the shaded in region. You can put vertical lines on here, like if you're wondering where 4 is, you can go to the draw menu and put it there, but we can see that matches our graph. So anyway, that's what they're looking for, is that picture. So let's look at our next problem. And I don't think I have room here, so let me save that. Start a new session. This next problem is kind of a long one. Okay. There we go. 5. So we got y is equal to x squared. And y is equal to 2x plus 8. Oh, that's bad. I saved the little writing on that. I can get rid of it. Cool. I was trying to show something in class, and it's got a little red right there, but oh well. Be happy with what you got. Part A. It says find the area of the region by integrating with respect to x. Well, these are already in terms of x's, so that's good. This is type 1. We just need to figure out what our x values are. Obviously, the blue here is above the red. The blue is our line, 2x plus 8. So let's find the POIs. So we'll set x squared equal to 2x plus 8. Take 2x plus 8 over the left side, so we got x squared minus 2x minus 8 equal to 0. This factors as x minus 4 times x plus 2 equal to 0. Set each one of those equal to 0. And we end up with 4, and we end up with negative 2. And you can kind of eyeball that and see, that looks right. The graphing calculator is fantastic for you to pick out sign errors and so forth. So for our setup, we'll go from negative 2 to 4, and we want to put our graph that's above, whatever that might be, minus the graph that's below. dx. Okay, so we said the blue line is the graph that's above. It's above this if I look at it at any particular point. So I'll put 2x plus 8 here, and I'll put x squared here. Well, let me simplify a little bit. That gives me 2x plus 8 minus x squared dx. Add 1 to your power, divide by your new power. So 2x squared over 2. If you just got a number, you just put an x with it. Minus, add 1 to your power, divide by your new power. 4 to negative 2. Gives us x squared plus 8x minus 1/3 x to the third. So now I'll plug in 4. So I got 4 squared plus 8 times 4 minus 1/3 times 4 to the third. I'll also plug in negative 2. So I got negative 2 squared plus 8 times negative 2 minus 1/3 times negative 2 to the third minus. I oftentimes make a simple basic math error at this point, so I warn you ahead of time why you'll see me screw up. 4 squared is 16, 8 times 4 is 32, 4 times 4 is 16, times another 4 is 64, so we got minus 64 over 3. Here we got negative 2 squared, which is 4, 8 times negative 2 is negative 16, negative 2 to the third is negative 8, times a negative gives us a positive 8 over 3. Which gives us 48 minus 64 over 3, and minus negative 12 plus 8 over 3. So I got 48 minus 64 over 3. The negative there flips the sign of everything, so it becomes a positive 12. Okay, I'm not sure what that was. The green attack, I guess. Plus 12 minus 8 over 3. 48 plus 12 is, now that's really messed with my mind, 60 minus 64 and 8 gives us 72 over 3. Which gives us 60 minus 24, which gives us 36. That's our answer. You can also plug that in your calculator. This one right here, if I come here and do a y equals, clear that, down arrow, clear, oops, down, clear that. So you're putting in the 2x plus 8 minus x squared. And you do second, trace, and you choose the seventh one. Looks like integral. It'll come up and ask you for your lower limit. We're going to put in negative 2, enter. And then it'll come up and ask you for your upper limit, which was 4, enter. And tells you it's 36. Now, I really only like that if it comes out perfect. If you got an approximation, you should, in my view, do it by hand. Okay, that's part A. Now B. Let's do it with integrate with respect to y. This is harder, and what they're trying to demonstrate here is that you can do it both ways. One way will be really hard, and one way should be fairly simple. So you need to look for that simple way and do your setup accordingly. Well, we want to do it with type 2. So we want these to be x equals. So we're going to solve for x. Here I'll drop off my square root property. Put a plus or minus square root around the other side. Here I'll take the 8 over. Equals 2x. Divide both sides by 2. Which gives us 1/2 y minus 4 equals x. Well, let's find our POIs. I'm going to set these equal to each other. So I got plus or minus square root of y. equals 1/2 y minus 4. I want to get rid of the square root, and we do that by squaring both sides. Now, whether you square a plus or a negative, it just becomes positive, so that drops away. Square root cancels that, so this gives us y. And this side, if I multiply those together, well, let me go ahead and write it out, then I'll do it. So we got 1/2 y minus 4 times 1/2 y minus 4. So that gives us 1/4 y squared minus 2y minus 2y plus 16. Been better if I'd actually left it in this form right here, but oh well. Let me double check myself there. So then that gives us 1/4 y squared minus 4y plus 16. We'll get rid of the fraction by multiplying everything by 4. So I got 4y equals 4 times 1/4 y squared plus 4 times negative 4y plus 4 times 16. Those 4's cancel. We got y squared minus 16y plus 64. Get everything over one side, so we've got y squared minus 16y minus 4y plus 64. Y squared minus 20y plus 64. That factors as y minus 16 times y minus 4. Set each one of those equal to 0. Y minus 16 is equal to 0. Y minus 4 is equal to 0. And we get y is equal to 16 and y is equal to 4. Okay, so now for the setup. This is a little bit trickier if you look at the graph here. And I'm looking at the graph to the right and then the graph to the left. Well, I wish I could draw this. That red line I had right here, you see this breaks off. We said that 4 and 16 were our points of intersection. Well, a 0 is our starting place. So that's why it's really nice to have the graph to look at to kind of get a feel for it. So this is going to go from 0 to 4 and then from 4 to 16. So let's come here. 0 to 4. And I want the graph that's to the right minus the graph that's to the left. dy. And then this next one is going to be from 4 to 16. And again, we want our graph to the right minus our graph to the left. And dy. Well, if I look from 0 to 4 here, this curved graph here is to the right, and this curved graph here is to the right. Well, that was my original parabola, and I solved it for x. We got plus or minus square root of y. Well, that's our x value. This side is our positive version, because this is where the x values are positive. So that's going to be graph to the right. Now here, our graph to the left is the negative version of that. So we're going to have negative square root of y. And then from 4 to 16, this curved part is to the right. And this is, again, the positive square root of y. And my graph that's to the left is this blue line, which it was the 1/2 y minus 4. And now we're ready to do our integral. And I'm just about out of space right here. Oh well. I don't think I'm smart enough to actually edit copy, but I'll try. So I'd really like to do the complete problem here. So we got square root of y minus minus becomes a plus. So square root of y plus square root of y dy. And over here, I'm going to rewrite that as y to the 1/2. And that negative flips the sign of everything into parentheses, so that's minus 1/2 y plus 4 dy. And then this Square root of y plus square root of y is 2 square root of y. And specifically, it'll be 2y to the 1/2. Because we want it in that form to easily find the integral. And there we go. Now let me save this, and we'll try to edit copy it and see if I'm successful. Otherwise, we'll just assume that the answer is 36 also, which is what we found the other way. They should be the same. I didn't think it would take more than one entire page. Okay, now I assume first I have to select it. This looks like cut or something like that. Oops. Obviously, that's not what I think it is. Maybe there is no edit copy capture screen. Well, obviously it's not going to let me. Okay, I'll give up that idea. Wow. I'm not going to be very happy if I actually cause that to crash. I may have to start cursing. Oh, there it is. Yeah, end that. Okay. Okay, well, it should have gave you the same value if we went and done it, but we'll assume it did. And go on to the next problem. Let's just say it's a lot easier to do it since everything was already set up with respect to x. It was a lot easier to use type 1 on that one. Okay, so we got y is equal to x squared minus 3. Y is equal to negative 3x plus 1. And we've got our limits from negative 2 to 0. So they're telling us to what the lower and upper limit's going to be. Let's graph this. I don't need a calculator for that. But you can plug, if you were doing it, put this in y1, put that in y2. X squared minus 3 looks like this, more or less. Negative 3x plus 1. 1, 2, 3. Looks like that. From negative 2 to 0. If I had drawn it a little bit better, I think we'd see which one was above. Now let me show it on the calculator. So press y equals, press clear. We got x squared minus 3. And negative 3x plus 1. And then let's graph. Now we're looking at it from negative 2 to 0. Boy, what did I do? 1, negative 3. Oh, man. Boy, that was pretty bad. Oops. Gotta do that with the pen. Kind of blew my mind with my having to blow up my tablet there. I can't even graph a line. That's bad. Here's 1. Go down 3. 1, 2, 3. Right 1. And of course this version's better. All we're trying to do is see what's above and what's below. So obviously the line is above. So let's set this up. Negative 2 to 0. And the line is above, so we've got negative 3x plus 1 minus the graph that's below, which is x squared minus 3, then dx. We'll do a little bit of simplifying. So we got negative 3x plus 1. That negative there flips sign, so it becomes negative x squared plus 3 dx. So we got negative x squared minus 3x plus 4, like that. So we'll add 1 to our power, divide by our new power. Add 1 to our power, divide by our new power, and 4 just becomes 4x. Now when I put 0 in there, the 0 is not going to do anything. So we just got one big 0 there. Because if I put this 0 in here, 0 to the third is 0, times that is 0, this is 0, this is 0. So we just have to worry about negative 2. So I got negative 1/3, and then negative 2 to the third power, minus 3/2, negative 2 squared, plus 4 times negative 2. Negative 2 to the third is negative 8, times the negative gives us positive 8/3. Negative 2 squared is 4. Times 3 is 12. Divided by 2 is 6. Boy, my mind's just blown from that tablet mishap. Okay. I have to double check this after I get done. Need to see if I need to record it again if I get any errors. Negative 6, negative 8 is negative 14. If I had that written down, I could have just copied it, but I didn't have it written down when it crashed. Now this is a mixed nut. Well, actually, let me go ahead and flip the signs first. So that gives us negative 8/3 plus 14, and this is a mixed number. 14 times 3 gives us 42. 42, and then we add the negative 8, which gives us 34. So we got 34 over 3 as our answer. Oh. For some more math, you get calm. First, the green screen of death was trying to take me, and then tablet was doing it. Okay, 7. I'll quit whining here eventually. Okay, so we got f of x is equal to x squared plus 8x, and g of x is equal to 0. Well, if I graph this, I'm going to see that the 0 is above the x squared. Is that a true statement? Let's see if I found a standard form for this. 1/2 of 8 is 4, so that'd be 4 squared 16, so that'd be plus 16 minus 16. Yeah, it'd be the 0 is above. So let's look at that just to verify that. Okay, so we got x squared plus 8x, and then graph. Okay, so that's what a picture looks like. So something like that. So let's first find our POIs to see what the area is bounded by, because this is our what we're trying to find here. So I'm going to set this equal to that. So we got x squared plus 8x equal to 0. I'll factor out GCF of x, and that gives us x plus 8. Set each one of those equal to 0. And we got x equals 0, and x is equal to negative 8. So I got negative 8 there and 0 there, and we want our graph that's above minus our graph that's below, dx. Now, if the graph above is a 0, that's the this line right here, the x-axis, and the graph that's below is the x squared plus 8x. So we've got negative 8 to 0. The 0 doesn't do anything there. The negative here flips the sign, so we got negative x squared minus 8x dx. We'll add 1 to our power, divide by our new power. Add 1 to our power, divide by our new power. And then our numbers here, which gives us negative 1/3 x to the third minus 4 x squared. Now if I put this 0 in, again, it doesn't accomplish anything, it just gives us a big 0. You could plug it in if you don't see that. But let's plug in negative 8. So I got negative 1/3 times negative 8 to the third minus 4 times negative 8 squared. And what does that give us? 2, 3, 512? Yeah. Not sure why I got the extra 2 there, but okay, minus, and this is negative. To take a break after this. Okay, so negative 512 times a negative gives us positive 512. And then we got negative 256. Negative 8 squared is 64 times 4 gives us the 256. That negative there flips the sign of both of those, so that's 512 over 3 plus 256. Negative. Okay. Now I'm going to, this is a mixed number, so I'll take 256 times 3. That gives us 768 minus the 512. Gives us 256 over 3. Assuming my mind isn't completely gone from earlier. I really will quit whining about it here eventually. Let's see, negative x squared minus 8x. And then I'll do second trace, choose my integral one. And negative 8 and 0. 85. Yep, that's right. Okay. So let me save that. There. And let's look at the next problem. So, number 8. We got y is equal to x plus 1. Y is equal to 5 minus x. And y is equal to 1. And this really would be perfect to show this in WinPlot, but I'll use the calculator. Okay, so I'll go to y equals clear. I'm going to put in the x plus 1 on y1. Down arrow, put in 5 minus x. So I'm putting each one of them on their own separate line. Down arrow, and then 1. Now the 1's going to be obvious to spot, and these others wouldn't be too bad. But I'm going to come over here to the far left where the first slash is, and I'll press enter 1 time. And that'll make it a thick slash, so we can definitely tell the difference. So this one is our thick slash, and this is the normal, and this one will be the line that's straight across. So let's graph this. Excuse me. Graph. Now I'm going to zoom in on that, so I'm going to press zoom, and I'll choose Z box. Now I'm going to up arrow. Put my cursor somewhere, I don't know, right there maybe. Press enter. And I'll down arrow. I'm trying to put a box around the area that's bounded by these 3 graphs. And once I get down to there, then I'll press enter. And it'll zoom in on just that piece. Now, I'll forget to do it at the end of this problem, but to set it back, you choose zoom and choose Z standard. So, now if I look at this graph here is above this straight line, which is our y is equal to 1, from this value to this value. And then this line is above this line from here to here. So I need to find out what those are. This one looks like it's 0, but you can't assume anything. Now this is the intersection of the thick line and y is equal to 1. So let's come over here, and we're going to find out POIs. So the intersection of the thick line, which was the x plus 1, and y is equal to 1. Take the 1 over, and we get x is equal to 0. That's kind of what we thought, wasn't it? This next one, we're wondering what this value is right here. It looks like 2, doesn't it? But this is the intersection of the thick line and the normal line. So thick line and normal line. So I'll set those equal to each other. Excuse me. Get all the x's on one side. We get 2x is equal to 4. Divide both sides by 2. And we get x is equal to 2. No big surprise. That's what it looked like. And then this right here looks like 4, but we'll verify that. That's the intersection of the normal line and y is equal to 1. So the normal line, which is 5 minus x, and then y is equal to 1. So I'm going to take negative x to the right side, 1 over the left. So we got 5 minus 1 is equal to x, or x is equal to 4. Okay, so now we're ready for the setup. So I'll go from 0 to 2. And again, we want our above and our below. Well, the above is the thick line from 0 to 2. Thick line was the x plus 1. And of course, the one that's below is the y is equal to 1. dx. And then we're going from 2 to 4. And again, we want our above. And we want our below. Well, from 2 to 4, this is our one that's above, which is the normal line. So we got 5 minus x, and then that's 1 again, dx. This actually is symmetric. We found that out in class. So you could just find from 0 to 2 and then multiply your answer by 2. But let's go ahead and continue with this. Okay, so the 1 minus 1 drops away, so this just gives us x dx. And this one here, we got a negative x, and this is a minus 1, so 5 minus 1 gives us 4 dx. So we'll add 1 to our power, divide by our new power. And here, add 1 to our power, divide by our new power. And for the 4, we just put an x on it. So put 2 in, so we got 1/2 times 2 squared minus 1/2 times 0 squared plus, then I'll put the 4 in. I'm starting to relax after that problem. Negative 1/2 times, watch me have something else happen, 4 squared plus 4 times 4 minus, and then we'll plug in a 2. So we got negative 1/2 times 2 squared plus 4 times 2. This is 0 squared is 0 times 1/2 is 0, so that drops away. 2 squared is 4 times 1/2 is 2. 4 squared is 16 times 1/2 is 8, so that's negative 8 plus 16 minus 2 squared is 4 times 1/2 is 2, so that's a negative 2 plus 8. That gives us negative 8 plus 16 is 8 minus negative 2 plus 8 gives us 6, which gives us 2 plus 8 minus 6 is 2, so it gives us an answer of 4. And that's our answer. And I probably have room there for the next one. Okay. So we got f of y equals y squared minus 3y, and g of y is equal to negative 3y plus 4. Now let's pretend that these look like this. F of x is equal to x squared minus 3x, and g of x is equal to negative 3x plus 4. And now let's graph these. Again, I want to clear out the y1, y2, and y3. On the newer version of the TI-84, when you do a clear, it doesn't clear out that thick line. So I'm going to left arrow over and press enter on that. Enter again, and again, one more time, and how many more times I got? There we go. Don't know why it doesn't clear it out. And let me graph x squared minus 3x. And then negative 3x plus 4. Then graph. Oops. Let me choose zoom. And choose Z standard. It's number 6. Looks like that. Now, if I were to take that, I switched my variables. If I were to take that and rotate my entire calculator, and I always have to think this through which way, let me see, counterclockwise, then I'd get what my picture would look like. I think it's counterclockwise. I'm a lot better if I have a calculator in my hand when I do that. But basically, whether you have it this way or you have it rotated, the bounded area is still the same area. So there's no loss in us just using x's like that and doing it in this manner. Now, sometimes there may be, depending upon what else they give you in a problem, but in this one there isn't. So let's find our POIs. So I'll set the x squared minus 3x equals negative 3x plus 4. And, of course, both sides have negative 3x, so those cancel out. And we get x squared equals 4. Drop the squared, put a plus or minus square root around the other side, and we end up with plus or minus 2. Okay, so let's do our setup. Negative 2 to 2. We'll put our graph that's above first. The graph that's above is that straight line, which is the negative 3x plus 4, minus the graph that's below, which is the x squared minus 3x dx. A little bit of simplifying first. So we got negative 3x, ooh, am I running out of space? Plus 4 minus x squared plus 3x dx. Which gives us negative x squared, negative 3x plus 3x cancels, plus 4 dx. You could use some symmetry here. Negative x squared plus 4. This is an even function, so we could actually look at it from 0 to 2 and multiply it by 2. But let's pretend I don't see that. We'll add 1 to our power, divide by our new power. And then the 4 becomes 4x with these. Okay, so I'll plug in the 2. So we got negative 1/3, 2 to the 3rd, plus 4 times 2, minus, and then negative 1/3, negative 2 to the 3rd, plus 4 times negative 2. Again, using the even and odd properties really does save you steps on these. We wouldn't even have to worry about it if one of those was 0. A lot easier to work. 2 to the 3rd is 8 times that gives us negative 8/3. 4 times 2 is 8, minus negative 2 to the 3rd is negative 8 times a negative gives us positive 8/3. That's negative 8. So that gives us negative 8/3 plus 8 minus 8/3 plus 8. That flips the sign of both of those. which gives us negative 16 over 3 plus 16, which gives us 32 over 3, I believe. 16 times 3 is 48, minus 16 gives us 32 over 3. And that's our answer. Okay. Time for it to blow up. Not that I haven't had a lot of things already blow up, but... Okay, let's look at the next one. It's a trig one. So we got y is equal to 2 plus sine x. And then y is equal to 3 minus sine x. Well, let's first find out where our POIs are. So I'm going to set those equal to each other. So I got 2 plus sine x is equal to 3 minus sine x. I want to get everything with a trig function over one side. So I'll take the negative sine x over the left side, and I'll take the 2 over to the right. So that gives us 2 sine x equals 1. Divide both sides by 2, and we get sine x is equal to 1/2. Well, remember this, if we looked on our unit circle, we talked about this earlier in this lecture. Here, we're going to find this is, try it again. Okay. This one is square root of 3 over 2 and 1/2. And this is pi over 6. And then over on this side is negative square root of 3 over 2 and 1/2. And this one is 5 pi over 6 if you look in your unit circle. So our intersections are pi over 6 and 5 pi over 6. Okay. But they're asking us to look between pi over 6 and 5 pi over 6. So they already give us those intervals. The only thing we have to determine is which one's above and which one's below. Now, they don't intersect in between here, so we don't need to worry about that part. So let's graph these. I'll go to y equals, clear, and I'll clear both of those out. And there's 2 plus sine x. So 2 plus sine x. Don't have to have the closing parentheses, but 3 minus sine x. So 3 minus sine x. Now make sure I'm in radians. So I'm press mode and I'm in radians, so that's good. I'm going to go in my window settings, which my eyes aren't so good, so I don't see that, but here's window, I think. And for the x min, I'm going to put pi over 6. That's all I'm concerned with. So I'll do second caret divided by 6, enter. And for the x max, I'm going to put in 5 pi over 6, my upper limit. So 5 second caret divided by 6. For the scale, I don't know, pi over 12 maybe, second caret. Not that really matters, because we just want to see which one's above and which one's below. 12, like that. Y min, I can see from here that that's actually good enough, but if I didn't see it, maybe I might play with these a little bit. I might do negative 4, put 4 in, like that, so I can see it a little bit better. But let's press graph. First I'll go back to y equals. Remember 2 plus sine x. Let me write these over here. So y is equal to 2 plus sine x, and y is equal to 3 minus sine x. Y is equal to 2 plus sine x is on y1, which means it'll be the first one to graph. So let's watch it. Push the graph. There's y1. And there's y2. So again, the 2 plus sine x was the first one, and obviously it's on top. So this is the one that's above, and this is the one that's below. You could always come back here and put like a thick line on one of them to easily tell. Okay, so let's do this problem. So we're going to go from pi over 6 to 5 pi over 6. Our graph that's above, which is 2 plus sine x, minus the graph that's below, which is 3 minus sine x dx. Okay, do a little bit of simplifying. We got sine x here. Negative gives us a positive sine x, so we got 2 sine x. And then 2 minus 3 gives us negative 1 dx. Then we'll find the integral of that. Now, remember going backwards, sine and cosine kind of flip back and forth. But when you take the integral of sine, that gives you negative cosine. You have to think of it, the derivative of sine x gives you cosine x, and then derivative of cosine x gives you negative sine x, so negative gives you that. And then this gives us just a negative x from pi over 6 to 5 pi over 6. So let's plug that in. So we got negative 2 cosine 5 pi over 6 minus 5 pi over 6 minus, and then negative 2 cosine pi over 6 minus pi over 6. Now if we look on our unit circle, cosine 5 pi over 6, here's 5 pi over 6, and remember this was negative square root of 3 over 2 and 1/2. So cosine is our x part, which is this. So we're going to have negative 2 times negative square root of 3 over 2 minus 5 pi over 6. And cosine of pi over 6. Over here, we're square root of 3 over 2 and 1/2. Cosine is our x part, so this is square root of 3 over 2. We already have a negative 2 in front of it, though. Square root of 3 over 2 minus pi over 6. Well, let's 2's cancel. Negative gives us a positive, so we got square root of 3 minus 5 pi over 6. Those 2's cancel there. We got negative square root of 3 and minus pi over 6. So square root of 3 minus 5 pi over 6. Negative flips the sign of both of those, so that becomes plus square root of 3 plus pi over 6. That gives us 2 square root of 3. Negative 5 pi over 6 plus pi over 6 gives us negative 4 pi over 6, which gives us 2 square root of 3 minus 2 pi over 3. Now, pi is like 6. 6 divided by 3 is 2, times 2 is 4. So that's like 4. 2 square root of 3. Let me exit out. So if I do 2 square root of 3, I got that correctly. Let me just see. 2 pi divided by 3. Okay, it isn't 4. What am I thinking? That's 3, that's 6. Oh, that is 2. Okay, I'll wake up here eventually. You'll know you did it right for your setup in terms of above and below if you end up with a positive number, which we will in this case. Now I want to get a common denominator. So I'll put that over 1. And I'll multiply top and bottom by 3 here. So I got 6 square root of 3 over 3 minus 2 pi over 3. So we got 6 square root of 3 minus 2 pi over 3 is our answer. Okay, so let me save that one. And then let's do our last problem. Okay, so we got f of x is equal to cotangent x, and g of x is equal to 1. And they're asking between pi over 4 and 3 pi over 4. Okay, so let's first find our points of intersection, and then we'll look at the graph. So we're going to set cotangent x is equal to 1. Different ways you could do this. You could think it through. Tangent is y over x, so cotangent is x over y. And where it's equal to 1 at is where the x and y are the same on a unicircle. If I go around my unicircle, we got a point here, square root of 2 over 2 and square root of 2 over 2. And this is pi over 4. We also have this place right over here that's negative square root of 2 over 2 and negative square root of 2 over 2. And this is, what is this one? Pi over 4, 2, 3, 4, 5 pi over 4. So what we have here is we got x is equal to pi over 4 and x is equal to 5 pi over 4. Now all we're checking is to make sure there's not a point of intersection in between these two values. Pi over 4 is one of our endpoints, so we don't need to worry about that. And 5 pi over 4 is outside of this. So we can just directly go from pi over 4 to 3 pi over 4. We just need to know which graph is above and which one's below. Well, let's graph this. So I come over here. I'm going to go to y equals, press clear. And remember, we don't have cotangent on our calculator, but cotangent is 1 over tangent. So I do 1 divided by tangent, x. Down arrow, press clear, and I'll put 1 in. And we're going from, what, pi over 4 to 3 pi over 4. So I'll go back to my window. And I'll put in pi over 4, so second caret, divided by 4. Down arrow, and no memory, 3 pi over 4. So 3 second caret, divided by 4. And I'll have this change, the x scale by pi over 8 maybe, I don't know. Second caret. Doesn't really matter because we're just trying to see what's above and what's below. Those are probably fine, those y min, y max. So let's press graph. Now first, notice the cotangent is on y1, so it'll be what graphs first. Of course, this one will be obvious, it'll be a straight line. But if I press graph, there's our cotangent. And there's our y is equal to 1. So that's above, isn't it? So that helps us with our setup. Calculus used to be a lot harder before the calculator. Okay, so I'm going to go from pi over 4, and I think it was 3 pi over 4. We said that our line was above, so that's the 1. Minus our graph that's below, which is our cotangent. Okay, so pi over 4 and 3 pi over 4. And we got 1 minus, and I'm going to write this as cosine x over sine x. I want to show the U-substitution on this. Remember, one of the places we said we could set u is we could set u equal to the denominator. The 1 is okay. I'm just doing this piece right here. So u is equal to sine x. So du would equal to cosine x dx, which is perfect for this. So I could split these up. Pi over 4, 3 pi over 4, 1 dx, minus, and if I do my u substitution now, this will become 1 over u du. And I'm gonna write here that these are the x values. So x equals pi over 4, and x is equal to 3 pi over 4. again, I just replaced the sine x with u, and then the cosine x dx became my du. Okay, so the integral of 1 is x. And I need to keep these here. And then over here, the integral of 1 over u is natural log of the absolute value of u. And keep these here. Now plug these in, so I got 3 pi over 4 minus pi over 4. And here I'll plug my u equals back in. What did we say u equals? Sine x, I think. U is equal to sine x, so I'll plug that back in. So I get the absolute value of sine x. And I'll flip these back to just 3 pi over 4 and pi over 4. Now 3 pi over 4 minus pi over 4 is 2 pi over 4. Here I plug in these values. So I got natural log of the absolute value of sine of 3 pi over 4 minus natural log of the absolute value of sine of pi over 4. This is pi over 2. Now in your unit circle, pi over 4 is right here, and it's square root of 2 over 2 and square root of 2 over 2. 3 pi over 4 is right here, and it's negative square root of 2 over 2 and square root of 2 over 2. So we got sine 3 pi over 4. If I look at sine 3 pi over 4, the sine is our y, which is square root of 2 over 2. Minus natural log, and then sine of pi over 4, well, sine is our y again, so it's square root of 2 over 2. So you see something nice happens. These are both the same, so they drop away, and our answer is just pi over 2. And that's the last problem, I believe. So with a few technical glitches, got through it. So I'll go ahead and stop the recorders here, if I can find the recorders. Where's the recorder? There it is. And was it F10?